Good morning, guys. Welcome to today's lesson, April 21st, area of a sector, day 2. The do now, the accompanying diagram shows two intersecting paths within a circular garden. What is the length of the portion of the path? Marked X. So these two paths that cross, they are chords within a circle. Here's one chord, and here's another chord. Now, the way you solve something like this, you take the two pieces that make up the chord and multiply them together. For example, the green chord here would be 10 and 6. We multiply those together, and we set that equal to the product of the other two pieces of the other chord multiplied together, right? So it would be 5 times x. Those are the two pieces multiplied together for the blue chord. All right, you have a question like this in Delta Math, so this is a good review. All right, so we get 60, just simplifying here, is equal to 5x. A nice one-step equation. And you get x is equal to 12, choice 4. All right, our aim, right, how do we find the area of a sector? Now this is that important of a lesson where we take 2 days, area of a sector. All right, it's good geometry skills, it's also good algebraic skills when you have to solve for something like, sometimes you have to find the area, sometimes you have to find the central angle x. All right, and just remember where this formula comes from. Area of a circle is pi r squared. Now this is just one extra step. We need a fraction in front of that pi r squared. Remember where that fraction comes from. 360 degrees, that's the entire circle. All right, x is that central angle. So we're multiplying the area of the whole circle by a certain fraction. Why? Because a sector is just a piece of the circle. It's a certain portion, all right, of a circle. All right, so define the area of a sector of a circle provided the radius or the diameter, and x, remember x is that central angle. All right, it's the angle that's meeting at the center of the circle, and it's for that sector. All right, so let's take a look at a couple examples, and then you'll get an opportunity to practice. This is one of those days, guys. You already have the rule. You already have a lot of the foundation. You can practice the whole worksheet on your own and then check the answers. All right, but I will go through a few with you. So this first one here. In the diagram below of circle O, GO is equal to 8. You can see that that's the diameter, the radius. And angle GOJ is equal to 60 degrees. What is the area in terms of pi of the shaded region? So this is one of those they try to trick you guys. The shaded region, the central angle, really goes from here all the way around to there. It's not that 60-degree angle. Why? Because that's not the shaded region. All right, the shaded region, so if we did 360 minus 60, we would get 300 degrees. So a very large central angle, but you think about it, that shaded region is almost the entire circle. So let's substitute. Our formula, x over 360 times pi times the radius squared. So your central angle is equal to 300 degrees. A lot of students would use 60 over 360 times pi times the radius for the circle, still the same. For the non-shaded and the shaded, same radius, times 8 squared. And since we're leaving it in terms of pi, we'll just multiply these two pieces in our calculator. So 300 over 360 times 8 squared, and you get 160 over 3, which you can hit on that little purple box to get the decimal version, but they have it in fraction form. So our area would be 160 over 3 pi units squared, which is choice 4. Once again, not an overly challenging problem if you know your formula. Remember, that's a formula that's not given to you, but they're trying to trick you. They're trying to make you use that 60-degree angle. All right, another one. A circle with a diameter of 10 centimeters and a central angle of 30 degrees is drawn below. What is the area to the nearest tenth of a square centimeter of the sector formed by the 30-degree angle? So we're dealing with this sector right here. No shaded or unshaded. We're focused on that sector there. This is more similar to your delta math type of question because they're actually multiplying it out and asking you to round to the nearest tenth or the nearest hundredth, so you're not leaving it in terms of pi. So once again, in delta math, you have to actually multiply it out with the pi. Alright, so once again, it's good to always write your formula. X over 360 times pi r squared. So our central angle is 30 over 360 times pi times, be careful with not using 10, right? That's the diameter. We want to use the radius. And now we're going to multiply that out exactly as we see it, not just the 30 and 360 and 5 squared, but include the pi as well. And we get 6.5 and change. Which would be, you can see, choice 2. Alright. Now, next one. The area of a sector of a circle with a radius of 15 centimeters, alright, is 75 pi centimeters squared. So you have a radius that's 15 centimeters, and you have the area of the sector. They tell you the area of the sector is 75 pi centimeters squared. What is the measure of the central angle that forms the sector? Now, there's no diagram, but that's fine. You can make a circle if you like. All right, but you know your formula. So now we're substituting our area this time. You remember questions like this from yesterday? 75 pi is equal to, we're trying to find the central angle, so x is actually x, what we're looking for, times pi times the radius of 15 squared. Very good to see the algebra here, guys. Now, what you got to do, pi is on both sides, you can get rid of it. We're going to rewrite the problem as 75 is equal to x over 360 times 15 squared, which is 225. Now we divide out the 225. We're getting everything away from x. So divide out your 225. Your 225 is gone. Now, 75 divided by 225, you're going to get some decimal, but you don't want to write it out. All right, you want to keep it as a fraction. See, that's the easiest way, I think, at least, to solve. So your 75 over 225, don't actually divide it, just leave it as is. So essentially what you're left with on the left side of the equation is 75 over 225, and on the right side of the equation, you're left with x over 360. So now just a proportion. Cross multiply. So you get 225 times x, which is just 225x. 75 times 360 is 27,000. And you get 120 degrees. All right, so what I'm going to have you do for today is the first one, you're going to practice finding the area, and the next one, you're going to practice finding the measure of the central angle. All right, now, I post the answers, remember, every single day, but more towards, the nighttime, maybe 6, 7, 8 o'clock at night. So if you don't happen to check at night to see how you did, honestly, that's fine, but what you should do to start the next day prior to watching this video and doing the lesson for the day, you should check in with the answer key from the day prior, just so you can see how you did. That's what's really, really important here. You getting the practice and checking your answers. Now, once again, you don't have to check them at nighttime. You can check them the next day prior to starting the lesson. Just check in. All right, I got this one right. I didn't get this one. What did I do wrong? Maybe ask a question. All right. And that's really it. Your Delta Math is due Thursday at 8 o'clock. Ask me questions and remind anything about the lesson, about Delta Math. Do not hesitate to check in. Have a wonderful rest of your day, and I'll see you mañana.